So alright, so let's continue with the mapping and function. What we want to consider now is composite mapping and inverse of a mapping. So in our previous video, we have talked about the preambles to mapping, all the definitions of function and relations, the definitions of mapping and the examples under it, all the definitions of domain, codomain and range, and also types of mapping. So now we want to see composite and inverse mapping. So from the word composite means what? It comprises of what? Two or more things. That's the meaning of composite. So a mapping is said to be composite if it comprises of either one-on-one mapping and onto mapping, or two one-on-one mapping. Like what I'm saying is that your what is it called? Your mapping can be composite if number one, you're having one-to-one mapping map to one-to-one. You get? Also, it can also be one-to-one map to onto. It can also be onto to onto. Onto to what? Auto. So all these one like this, they are called bijective mapping. That's why they are called bijective. Bijective mapping. So your map can be what? Composite if it is one-to-one to one-to-one, one-to-one to onto to what? So let's see this diagram. So this diagram really explain what we mean by what? Onto mapping. So composite mapping. Sorry. Now let's say we have a mapping. X is mapped to what? Z, mapped to what? Y. Function F, G. So then we have P, Q, R, S. We have A, B, C, D. Then we have X what? Y, Z. X, Y, Z. So this is mapped to this as is in the diagram. S is mapped to B, Q is mapped to C, and R is mapped to D. Now from this place, A is mapped to X, C is also mapped to X, B is mapped to Z, B is mapped to Z, and D is mapped to X. D is mapped to X. So look at this diagram now. Look at this. You can see that this is what? P mapped to A, right? How many elements here? We have 4. We are also having what? 4 here, Abi? You can see that this is what? P mapped to A, Q mapped to C, R mapped to what? D, and S mapped to B. You can see that each element in the domain is attached to what? Each element in the codomain. You can see that this is what? This is what? 1 to what? 1. And look at this now. So this one is serving as what? This one is serving as the image of this one. Now for this one will be serving as domain, this one will be serving as what? Image. So now look at this. A produce X. The same C also produce what? X. So that means you are having the element in the word codomain that's having at least one image from the what? From the domain, which is this one. This one is the domain. So you can see that you are having 2 elements in the domain that is producing one what? One image, one codomain. So this is what? Onto, Abi? This is onto. This is onto. So you can now see 1 to 1 with what? Onto. So it can be 1 to 1 with onto. It can be 1 to 1 to 1 to 1. It can be onto to what? Onto. So far that you are having more than 2 mappings. So that's what we call what? Composite mapping. Also, I forgot something when I was explaining the onto mapping. You see, in one-to-one mapping, most of the time, one-to-one mapping, the range is not always equal to the domain or the codomain. Like, for example, if you look at this one now, look at this one. The range, what is the range here? We say that for this, let's just say between this and this. What is the range here? The range for this one-to-one. The range are what? Are the what? The elements in the codomain that have image in the what? In the domain, abi? So what are the range here now like this? A, B, what? C, D. So which is 4? You are having 4 elements there, right? Now look at this. What is the range here also? What is the range here as well? 1, abi? 2. So the range here is also, this is Y, sorry, X, Y, Z. So look at this. You are having range here to be 4, and which is the same thing as the number of codomain. You are having range here to be 3, which is the same thing as the what? The number of what? Codomain. Now, the reason why you are having this is special. Most of the time, let me give one example. So that you can understand better of what I'm trying to say. Now, for example, look at this example where you are having x mapped to y, function of x. So you are having a, b, c, d. Then you are having 1, 2, 3, 4, 5. Now, a goes to 4, b goes to 5, c goes to 1, and d goes to 2. Now look at this. Of course, if you look at this example, this is what? One-to-one mapping, right? This is one-to-one mapping. Yes, this is one-to-one mapping. But the range here is what? What is the range? 1, 2, 3 what? 1, 2, 4, and what? 5. So how many range do you have? 4. And what is the number of codomain that you have? 5. So most of the time in your one-to-one mapping, most of the time the range you get is not always equal to the number of range is not always equal to the number of what? Codomain. But in composite, most of the time the number of range is always equal to the number of codomain most of the time. You understand? So now let's now continue. That's by the way. So I will now give examples to calculations that is under composite mapping. So let's see 2 calculations under composite mapping. 2 calculations. Number one. Look at this example. They say let function of such that s is mapped to y and g such that y is mapped to z be mappings. They say let all these be mappings on the set of real numbers divided by f of x equals to x plus 1 and g of y equals to y plus 1 square. They now say find g composite f. That's the first one. The second one. So I'm going to solve 2 questions under it. 2 questions. Question 2. The same story. The same let f of x equals to all this like this. They now say divide by f of x equals to 2x plus 1. G of x equals to x squared minus 3. And h of x equals to 3x plus 2. You now say show that open bracket f composite g composite h is equals to f composite open bracket g composite h. So let's see these two questions. Solution. Now for the first one, we said let all this be mapping on the set of b numbers divided by f of x equals to x plus 1, g of y equals to this. You now have to find g composite f. In mapping, this symbol like this is always used to represent composite mapping. So how do you find composite g of x? So now this is the meaning. G composite f simply means you are writing g first. G is your what? Is your domain. So what is your g? G is what? Y plus 1 square. You are writing it first. Is your domain. Now composite f means that this value of y in g, you'll be looking at y as the what? Function as the f of x. So all this y, you'll be looking at it as if you are having f of x there. So your y, you now replace it with what you have as what? As f of x. What do you have as f of x? You have x plus 1. So instead of y, instead of this y, you now put this value, x plus 1. Then you're having plus 1 there again, plus 1 all square. So now we're going to have x plus 2 square. So open this bracket. If you open this bracket, you're going to have what? G composite f equals to what? X plus 2 into x plus 2. So x times x square, 2x, 2 times x, 2x, 2 times 2, 4. So you have x square plus 4x plus 4. So that's your G composite f. So what if I want to find f composite g? The same thing. F composite g, you are writing that means f composite g, you are writing your f first, right? You are writing your f first, which is x plus 1. Then you'll be looking at this x as if you are having g there. So you will, instead of this x, you replace it with everything you have at your g of y. So what do you have there? You are having y plus 1 square. You replace it with x, then you are having plus 1. So you now open the brackets. So you are going to have y plus 1 into y plus 1, then plus 1. So f composite g will now be equals to y times y square, y times 1, y plus 1 plus 1. Then finally you have y square plus 2y plus 2. That's your f composite g. You get? So let me do question number 2. So question 2, still the same story. You are having f of x, g of x, and h of x to be the mapping. He now asks you to show, you want to show here. See, all these questions like this, they are inside materials or handout. You have to cram them with the answer. You know these questions like this, you might see them. So you're not wasting your time again. You just know the answer already, just pick it. So f, question 2, our f of x is equals to 2x plus 1. G of x equals to x squared minus 3. H of x equals to 3x plus 2. You now say we should prove that f composite g composite h is equals to this. Now, we firstly solve this one. You solve this one. So, once you solve it, you now compare if the answers are the same, because we are asked to what? To prove. So, now, we want to prove f composite g composite h first. So f composite h means you first consider f composite g. That's the meaning. F composite g. That's what you firstly do. So f composite g, where is your f? F is 2x plus 1. Composite g means you replace this x with everything you have in what? In g. So you have 2 open brackets. Instead of x here, put everything you have there. You have x squared minus 3. then plus what? Plus 1. So you have replaced it. Then you are going to have 2x square minus 6 plus 1, abi, which is 2x square minus 5. That's what you have. Now, f composite g like this, come and put it in bracket. F composite g is 2x square minus 5. Composite h. Composite h means that everything you are having here, you go and replace it with what? With what you are having in your h. Right? So, yeah, is that not the meaning? Yes, that's the meaning. That is, everything you are having here, where is your so 2x square minus 5, you firstly write it like this. You firstly write it. Then instead of x square that you have here, you're now going to be replacing it with what you have in what? In h of x. So anything in h of x, come and put it here. You are going to have 2 open brackets. What are you having? So you'll be seeing this x as what you are having in what? In h of x, which is 3x plus 2, but you are having square minus 5. Then f composite g composite h will now be open the bracket, 2 open brackets, 3x plus 2 into 3x plus 2 minus 5. Then we are going to have 2 open brackets, 3x times 3x, 9x square, 3x times 2, 6x, 2 times 3x plus 6x, 2 times 2, 4. Then you have minus 5. Then open the bracket, you are going to have 18x square plus 12x plus 12x plus 8 minus 5, abi? So you are going to have finally 18x square plus 12x plus 12x, 24x, 8 minus 5, 3. So this is what you have for the f composite g close bracket composite what? H. So let's prove the also f composite open bracket g composite h. You firstly prove this one that I have in the bracket, which is what? G composite h. So G composite h means you are going to write G first, abi? What is our G? G is what? S square minus 3. Then now I'm going to replace this s with the value you are having in what? H. So what I have in is 3x plus 2. So you are going to have 3x plus 2 square minus 3. Then for you open the bracket, you are going to have 3x will take power of 2. 3x square will give you what? 9x square. Then 2 times 3x, 6x. 6x times 2, you have 12x. Right? Then 2 will also take power of 2. That's for I'm using shortcut for you direct. That's the main. So if you want to use the shortcut, it's best you say 3x, this first value, everything square. You have 9x square. Use these two at the top like this. Use it to multiply 3x and also plus 2. 2 times 3x, 6x. 6x times plus 2, you have 12x. Then also, last one, let 2 take square. 2 square is what? 4. That's all you have. Open the bracket. Then minus 3. So then you are going to have 9x square plus 12x plus 1. That's what you have in the bracket. That means f composite open bracket, our g composite h is what? 9x square plus 12x plus 1. So f composite g, f composite everything, it means you are writing what first? You are writing f first. That's the meaning. You are writing f first. You are writing f first. So what is our f? Our f is what? Our f is 2x plus 1, right? F is, so therefore f composite g composite h, because of our f is what? 2x plus 1. So we have written f first. Now you are not going to replace all the value, you replace this x with everything you are having at your g composite h, which is this. So you are going to have 2 open brackets, 9x square plus 12x plus 1. Right? Then plus another 1. So finally, you are going to have 18x square, 2 times 12, 24x plus 2 plus 1. Then you are going to have 18x square plus 24x plus 2 plus 1 is what? 3. 18x square plus 24x plus 24x plus 3 plus 3. So therefore, F composite G composite H is equals to what? F composite what? G composite H, which everything is equal to what? 18x squared plus 24x plus 3. Proved. That's all. So and that's all about mapping or composite mapping. So also I will solve two questions under inverse of what? Mapping. Under inverse of the mapping, I will solve two questions. So in fact, inverse of the mapping is even the simplest one. It's like we are making something subject to formula. That's the inverse. So look at this. Given the following functions, find the inverse of the mapping A. Number one, we are given f of x equals to 1 over 2x minus 3. Abi, find f inverse of x. That's the meaning. F inverse. B, f of x equals to x plus 1 over x minus 2. So we find the f inverse. Also, 3, f of x equals to exponential x minus 1 plus 3. Find the f inverse. Then the last one, 4. Given the inverse function, f inverse of x equals to 2 open bracket x plus 3, find the function. Find the function. So alright, so this is where we are going to stop for today. Though there are some exercises that I will still be releasing under mapping and function. There are some exercises. Yeah. So but for today, this question I'll solve 1, 2 today. Then in my subsequent tutorials, so I will solve these two as well. Then other tutorial questions or other questions that you need to know under mapping and function, I will solve them. So let's solve these two. So the first one says what? Number 1, you have f of x equals to 1 over 2x minus 3. You have to find the inverse of this function. So the first thing you say you always let your f of x equals to y. Let f of x equals to y. So you are going to have y equals to 1 over 2x minus 3. You get? Now you make x subject to formula. That's what you want to do. Just make x subject to formula. How do you make x subject to formula? Multiply all 2 by 2. Multiply all 2 by 2. You have 2y equals to 2 times 1 over 2x minus 2 times 3. Abi 2 cancel 2. You have 2y equals to x minus 6. Right? Collect that time to make your x subject to formula. You have x equals to 2y plus 6. Abi? So you can now have x equals to 2 open brackets y plus 3 if you factorize. So you now say, since you have made x subject to formula, you now say therefore the inverse. You know that you say f of x should be equals to what? Should be equals to y. Abi? Aha. So therefore your f inverse of x, or let me do it like this in a layman level. You now replace x with f inverse of x and y with x. So after you have made x over the formula, you now replace x with what? So you just say f inverse of x, that's what you are looking for, equals to 2 open brackets. You replace y with what? X. So your inverse of x is equals to what? F inverse equals to 2 open brackets, x plus 3. That's all. Then the next one, I'm having f of x equals to x plus 1 over x minus 2. I want to find the f inverse of what? Of x. So let what? Let f of x equals to what? Equals to y, abi? So y equals to x plus 1 over x minus 2. So we want to make x always the formula. Collect cross multiply, you have y open bracket x minus 2 equals to x plus 1. So you cross multiply, now open the bracket because you want to make x solve the formula. You are going to have xy minus 2y equals to x plus 1. So you want to make x solve the formula, collect later, you are going to have xy minus x, abi, equals to what? 1 plus 2y, right? What is common here? X, abi? Factorize. Open bracket, you are left with y, you are left with 1. Everything equals to 1 plus what? 2y. Divide this by what? Y minus 1. Therefore, you have x equals to 1 plus 2y over what? Y minus 1. You can still write this one as what? X equals to 2y plus 1 over what? Y minus 1. Now, replace x with what? F inverse of what? Of x. Then, and y with what? With x. So, therefore, F inverse of x equals to 2x plus 1 over what? X minus 1. That's your inverse. So that's all for this session. Please make sure you refer, like if you are in any institution, any department that is doing mathematics, refer this tutorial to them, share to them, let them subscribe to our YouTube channels, let them follow all our social media handles at Lawrence Bashir Tutorials, let them react, comment and share, please, because after all this now, I'll still be releasing more explanatory videos, more comprehensive videos, more educating videos. Please share to them, let them know that we are giving the best explanation on this platform. So, and after this, I'll still be solving more tutorial questions, more examples that you need to know with their shortcuts. Thank you as you all watch.